In our second problem here, it's not as explicit in telling us what we're comparing. So I'm going to read through the problem again. Generally, the average price of going to the movies has steadily increased over time. Identify the independent and dependent variables, then sketch a graph of the scenario. So what two things are we comparing here? Right away, I notice that we're talking about the average price of going to the movies. But then what is it comparing to? So if we read through that again, the average price of going to the movies has steadily increased over time. That means I'm comparing time to the price of the movies. So I have to go ahead and figure out, well, what is my independent? And what is my dependent? So what depends on what here? And you can always phrase it in the same way. Does the price depend on what time it is? Or does the price depend on the year? Or does the year depend on how much it costs to go to the movies? Which one of those variables can be controlled on its own, and which one depends on the other one? If we think about it, time, whether we're talking about minutes, hours, years, time's going to keep going on. Time moving forward does not depend on anything else. Okay, so that's going to be my independent. But then the price of the movies, if it's changing as time goes on, price of the movies is dependent on the time. So my price depends on time. So then if I go ahead and draw in my graph, I have X and Y. I'm going to put time down here because time can be controlled on its own. I'm not saying I have control over time. I'm saying time is being able to be controlled by its own. It's not dependent on anything else. And then my price depends on time, right? So a couple years ago, it might have been a lot cheaper to go to the movies than what it is right now. So your price is dependent on what year we're in. So now I'm going to go ahead and think about what pattern might show up in this graph. So if I read it again, it says it has a steady increase. Okay, so a steady increase looks pretty similar to what we graphed here. Steady increase means my X and Y are increasing at the same time. If I'm talking about time, I can never stop time. I can never decrease time. We might talk about some examples about in a little bit later on what it would mean to move backwards in time on a graph. However, in this situation, time is always going to be increasing, and then I have a steady increase in price. So my graph is going to look the same. But I'm going to push you, I don't know what's going on there. I'm going to encourage you to try to think now, is there a different formation of this graph? So is there a situation where there might be a flattened curve? Is there a situation where you might be decreasing? So take a moment to think there. What would it mean if I had a graph that looked like this? Right? So I have time here and I have price here. Is it possible to have the same type of graph we were looking at in the ocean where I might be increasing and then flattening out? Oops. Increasing and then flattening out and then increasing. Would there be a situation then where I start to go down, and what would that mean? So really try to think, is there a situation where this is happening, or am I just definitely stuck here? So think about the difference there. Can you come up with something? Okay, but that takes us to the end of our notes for the day. So as long as you're finished here, your homework assignment is attached. You're going to work on this. If you have any questions about any of this stuff that we did, if you want to talk about what this graph might mean, if you have some ideas, join the Google chat during 7th period, and I'm going to be here.